Okay, guys, I just wanted to give you a little more information, just some facts and kind of an idea of when you are given certain information, exactly how we should progress. So, for instance, this first one here says that if I know I have a bisector, so there's different ways I could write that, right? Line K bisects AB, or K is a bisector of AB, or anything along those lines, then the fact is, we know that means I have two congruent segments created, and the reason I would use is the definition of bisector. So picture this in a proof. Say this was given information. This would be, you say this, I know left thing because of given. I know this because of the definition of a bisector. Okay, so kind of moving on, that's kind of how I want to approach all these things. So if I know I have two perpendicular lines, then I know, like if I was given that, then the conclusion I can draw is that I have two 90-degree angles. And the reason for that is that's the definition, right? And then from there I could go on and say maybe that AED was congruent or something like that. So we can kind of put those two ideas together and say, what if we knew AB was the perpendicular bisector? Okay, well what that would mean is I have a midpoint, right? I have the first thing, I know I have a midpoint, or also I could say that CM is congruent to DM. And I also know I have 90-degree angles. So the definition of a perpendicular bisector, tells us both facts, right? That I have a bisector and that I have the perpendicular. And those are, so I can draw two conclusions from that one statement. Next we say midpoint. So if you're given that M is a midpoint, then I know I can draw the conclusion that these two segments are congruent. And the reason is the definition. Okay, so continuing on. And I'm not trying to rush through this. I just don't think it's worth me talking a ton about. I just want to make sure, I want to show you a lot of common things that we keep seeing. Right, so for instance, you may just see that we have vertical angles. Well, what does that mean? That means that this one angle, let's call this 1 and 2, I would know that angle 1 is congruent to angle 2. We know that's true, and the reason is the vertical angles congruence theorem. Obviously, that's one we've used a lot. Okay, if I know that two angles form a linear pair, angles 1 and 2 form a linear pair based on the diagram, the fact that I know there's a line, then I know that the measure of angle 1 plus the measure of angle 2 is equal to 180, and the reason is the linear pair postulate. Okay, and so these things on the right, this right-hand column, all these reasons, we need to know these. We need to know the right vocabulary. Okay, if I know for a fact that two parallel lines are cut by a transversal, so I know these are parallel, then there are lots of things we can decide, right? I know that there's corresponding angles that are congruent, and that's because of the corresponding angle congruence postulate. Right? I also know that alternate interior angles are congruent. We see this one a lot in our triangle proofs, and the reason is alternate interior angle congruence theorem. We also know that consecutive ones add up to 180. Again, if these are parallel, I know that these two angles add up to 180, and that's a consecutive interior angle theorem. Right? So these are the ones that are going to pop up in proofs a lot. We also know alternate exterior angles are congruent if these are parallel, but that's not going to happen as often because if you think about with triangles and things, those are outside of the figure, so those don't pop up quite as much. What if we know that two triangles are congruent? Right? What if I know if the triangle ABC is congruent to triangle DEF? Then I know that all corresponding parts must be congruent, whether that's angle A is congruent to angle D, or whether it's side BC is congruent to side EF. Obviously, this is a big thing, and remember that I only use this after I already know that I have two congruent triangles. Okay, the order of this is very important. What if I know that two figures share a common side, like right here? Then I know that that side is congruent. If this were side BC, then I know that BC is congruent to BC, and that's called the reflexive property. This is also one I'm sure I didn't need to mention because we're very comfortable with it. Obviously, if two values are equal, then I know that I can substitute one for the other. Okay, this is called substitution property. We haven't used this as much, but we need to be comfortable with it. So for instance, let's go back to a perpendicular idea. If I know that these two lines are perpendicular, let's say this is A, B, C, and that's D, then if I know it's perpendicular, then the first thing I would say is that the measure of ADB is 90 degrees, and the measure of CDB is 90 degrees. And then the conclusion I can draw, and that was because of perpendicular lines. Well, I could use substitution now, or I could write one of these in place of the other whenever I wanted. Right, and that becomes big algebraically. Okay, if I have an equilateral triangle, of course what that means by definition is that it has 3 congruent sides. We could then prove, if we wanted to, that that's the definition of equilateral triangle. We also know that the 3 angles are congruent, but that would take a little work. There's a theorem there that we would need to prove. Isosceles triangles, of course, have 2 congruent sides. That's the definition. We know the definition of a rectangle is that it has 4 right angles. That could pop up. Another thing I could say is, like, if you're given a circle, if that's your given information, one thing I know always is that the radius is always congruent to any other radius. Okay, so we saw that in a proof the other day, where if I drew 2 different things, I knew their lengths were the same, and I could help draw triangles and stuff with that as well. And that would just be the definition of a circle. So a lot of these are very common sense, and we've used a lot, but I wanted to put it out there specifically exactly how one thing leads to the next. And so if you are trying to make a congruent statement to show triangles are congruent, then I might need to use a definition, I may need to use a given statement, I may have to string together a couple ideas to get to the conclusion I want. So I hope that was helpful, and please check out the answer keys of some of the proofs you should have tried. Remember, I wanted you to specifically look at, I think it was called Proof Worksheet 2. I really love you to see number 3 and 4 and 6. I think are very doable. So look forward to seeing you tomorrow. Thanks.